Ladies and gentlemen, I welcome you back to the Kerbal space program. In our current adventure, we are going to go where we have never gone before. In fact, we're going to go to two places we haven't tried going to before, in the same mission. There are two moons out here. We've got Mun, M-U-N, and Minmus, and if we zoom out even further, we have the deep outer reaches of space. This particular mission is going to involve trying to visit the moon, and then deep space. We're going to be skipping Minmus in this particular adventure, because checking out the moon and outer space is much easier. We are going to be conducting a flyby mission today. Now, as you can probably infer from that, flyby missions mean that we are going to be passing by the moon and then launching off into deep space from there. Because we don't want to permanently lose one of our Kerbals, we are going to be doing a satellite mission, which means that we're going to be launching a satellite which I have dubbed Lunar 1. Lunar 1, technically, was the first, historically, was the first satellite to ever visit the moon.
Soviet Russia scores a dramatic victory in the exploration of space with the launching of the first rocket to hit the moon.
It was intended as a impactor. An impactor is the sort of satellite that, a sort of probe that crashes into the moon deliberately to give you some data on the moon as it goes down. We are going to be reenacting a mission called Lunar 1, which was a mission that was supposed to be an impactor, but in fact missed the moon. Instead, it got slingshot from the moon by its own gravity and into the deep space area itself, where it attained heliocentric orbit, which is an orbit around the sun. We are going to be doing the same thing. So, this particular mission involves our satellite, of course. We've got some solar panels to give it energy on the way out, as well as battery packs all the way around here, which should give it sufficient fuel. We have science missions. We've got the Science Juniors, the goo experiments. We are going to try using our new thermometers while we are up there as well, to give us some thermometer data. I've learned since our last recording that thermometers can only be used when you're in close proximity of a certain area. If you're in deep space, a thermometer is not going to work, so maybe when we pass by the moon we might get some data on it, but otherwise not really. You may be wondering why I've equipped a parachute and landers on these. Since we're going to be going to deep space, and we're going to be in heliocentric orbit, we don't have to do this for this particular mission, but there is a very slim chance that we might encounter something there, and we want to be ready for it just in case. Other than that, I have equipped some energy to these lower capsules, because we might need it in case we don't get the sun for a little while. And we've also included these new boosters here. These are boosters that I've recently unlocked on the tech tree. They are called the Max solid fuel boosters. They are more powerful than our standard fuel boosters, and that's the sort of strength we need to get up to the moon with our heavy payload. The setup is otherwise the same. I've attached them to the lowest fuel tank here. We've attached these stabilizers down here. We are more or less good to go with what we have. I've tried testing this a couple times, and I've got it to work eventually, so we're going to give this a quick shot. We're going to save here and prepare ourselves for a launch. Right, it is the middle of the day or so, sun's just up in the sky there. We are going to quickly... let's see here, we're going to throttle up all the way, and we are now going to launch. Oh, actually, we're going to stabilize ourselves by pressing the T key, and now we're going to launch. 3, 2, 1, ignition! We're going to keep ourselves throttled up until our meters per second goes above 200, then I'm going to pull down the throttle using the control button here. Let's see, give it a little bit. A little bit more. And we are going to throttle down all the way to 0. Our solid fuel boosters will carry us quite a bit of a way up. Just before the solid fuel boosters run out, I'm going to throttle our main thruster back up, just like our our earlier missions. That should happen about now. And we're going to get rid of our boosters, considering they are no longer needed. We are above 10 kilometers, and we are going at a decent speed, so I'm slowly going to start aiming towards the east. Slowly this time. Instead of immediately heading for a 45-degree angle, I am slowly going to aim to the east, and we're going to look at our orbital map up here. Similar rules apply before going to the moon and beyond. We must first attain orbit, because it is much more practical to achieve an orbit and then decide where to go from there. So the orbit is the next rule or parameter that we're trying to hit. I am slowly again going to aim towards about a 45-degree angle. That's our ultimate thing for at least this first phase of the mission. Let's see. Very gradual. If the T-minus 27 seconds gets too low, then you want to aim a little bit more straight up. Or if it starts climbing up too high over a minute or so, you want to aim more, I believe you want to aim more towards the horizon. Again, slowly but steadily aiming this way, with 45 degrees being the penultimate direction until we achieve 100 kilometers. That is the magic number we need. Or close. I believe you can get away with it if you're going at, over 70, 80 kilometers, but 100 kilometers is a little bit more... I believe it's a little bit more of a stable orbit, because when you get a lower one, your options are a bit more limited. Okay, still aiming towards that 45-degree angle. Nearly there. When we hit 70 kilometers, I'm going to go full 45 degrees. I'm not sure if this is the best way to do it, but it's something I would like to try, just in case. Yeah, you know what? I'm just going to aim for that 45-degree angle now. There. And that should give us the ability to coast up to 100. I'm not sure how much fuel we have left at this point. Nearly there. Nearly... Okay, we've almost got this. And bingo. Okay, so let's see how much fuel we have left. Oh, not bad, actually. Okay, quickly, since we have about a minute and 40 seconds to go, I'm going to give ourselves an orbit here. We want to aim for about 100 on both sides. Oops, that's not what I wanted to do. 100 on both sides. Having it switch around like that does give you a good idea. I don't believe it has to be 100 on both sides, but it does help to have that available. Not perfect, I will admit. I'm not really good at setting up orbits. That's something I still need practice on. Let's see. We don't need to give ourselves that much of a boost. That's probably acceptable. I'm going to quick save right now, just in case this does not work, this maneuver. I'm going to aim it about here, and we are going to try to achieve a liftoff, or at least an orbit. I might have spent too much time thinking about it, however, because I only have 40 seconds to aim us towards that blue maneuver node that we just set up. But we're going to give it our try. We're going to give it our all. I've noticed with probes or satellites that it takes much longer to turn. I'm not sure if that is always true, at least with the Sputnik era probe that we've got going on there. I'm going to let go of the key right here. Going to start, we're going to let it coast. 7, 6, 5, 4. Even if we're not completely on the node, I'm just going to fire up the engine now. Because once we fire up the engine, it actually is a little bit easier to aim. Looks like we can achieve this orbit in about a minute or so. Less than a minute, but we're going to run out of fuel first. That is expected. Almost. We're not going to make it on this fuel cell, though. So we're going to have to quickly ditch that and fire again. Still full throttle. I'm gonna keep an eye on our orbital map here. And again, I don't believe our orbit has to be perfect, but I would like to have it over 70 meters on both sides, preferably even. Let's see how this is going here. Okay, still good. We're still right on the node. And hopefully 2 large fuel canisters is enough to get us to where we need to go. I'm wondering if it's a bit counterintuitive to have 2 fuel canisters, because while it does give us more boost, it does also give us more weight to push around. Okay, we're still more or less on the node. Again, we don't have to aim precisely for this, but preferably aiming for roughly, there. Roughly the same amount. When we get nearly there, the apoapsis and the periapsis should switch sides, as they have here. 15 seconds to go. As we get closer, it does sort of catch up. The periapsis now showing up. Once it hits above 70, we have achieved orbit, but I want to get a little bit higher than 70. 93 is what we got promised over there. Ooh, that orbit is nowhere near the same sort of orbit that we had planned. So I am not good at setting up orbits, I will admit. Actually, I don't want to waste too much fuel here. And maybe an elliptical orbit is a little bit better. So we'll see how that actually goes. I am horrible at setting up orbits, so let's see. Now, our target, once again, is the moon, the MUN, not the Minmus moon out here, but the moon, because that is our current next destination, and we want to learn a little bit about it. In order to achieve getting to a new body from the planet from which we originate, we must create a new node. I believe we want to do it about halfway between our periapsis or our apsis, or rather where we'd be able to catch the moon. I'm going to create a burn and try to plop it right on the orbit. But the thing is that, actually it'll be easier to demonstrate if we just do it like this. If I were to grab the center circle here and turn it like this, we wouldn't really quite be able to land on the moon, because even though our orbit reaches that point, the problem is that the moon will rotate, continue in its orbit. So we want to turn this until it quite accurately predicts where we are going to be, and if we turn it enough, pretty soon we should see. There we go. That's the moon encounter right there. However, we want to get a little bit closer. If we turn it like this, we'll get an encounter with it that'll put us at closest about a million kilometers. But we want a little bit more than that, so we're going to keep turning it. And again, we want to make sure that we get an orbit that puts us out of the Kerbal System. If we were to continue on this orbit, we would actually be kicked up from the moon. Kicked up from the moon like this, and go up in this new orbit. But we want to escape the Kerbal System altogether. So I'm going to aim it a little bit differently. There we go. Periapsis. Ooh, 45. That's the sort of orbit we want to hit, because that will get us really close to the surface at about 145 meters, and then the gravity from the moon will slingshot us further out into interplanetary space, which is where we want to go. So in order to achieve that orbit, we're going to have to adjust our probe here, our Lunar 1, to our new node. In fact, I'm just going to quick save before anything else happens. Sometimes the estimated burns aren't too accurate, so before I do an estimated burn, I am going to just do a very quick little trick that we can do here, which is to say I'm quickly going to Slightly hit up on the shift key to throttle up, and then immediately throttle down by pressing X. And that should improve our estimated number there. A little bit differently than how we get and achieve orbit, I believe what we can do to improve our numbers here is to start our orbit about halfway. Like if we put half of our thrust before the T-minus point and half of it afterwards, that should increase our chances. So first of all, now that we've aligned ourselves properly, I'm quickly going to throttle up and then throttle back down. 28 seconds doesn't sound quite right. I don't think we can do that in 28 seconds. See how the estimated burn number keeps going up and down. I am going to start this at about a minute before we really get going here. That's more or less what I've noticed. There's math involved in this, but I'm not very familiar with it. I'm going to quick save just before any of this happens. We're going to start now. And take a quick look out here to see where our orbit is. Now that we're launching, or thrusting, our apoesis, I don't quite know how to pronounce that, but we are now adjusting that. It is slowly reaching further and further out. We're going to keep this up until the line here matches our moon encounter indicator right there. Should take about 35 seconds according to the estimated burn time. Now, I probably started a little bit earlier than we should have, so I'm not sure entirely, again, if this is going to work. This is a test. And if not, we did quick save. So as this speeds up and as we get close, I'm going to start throttling down. Whoa! Throttling down, because now it's getting us close to the encounter that we want. So I'm going to keep an eye on this moon encounter node right here. When it matches the one down here, let's see actually, let me keep an eye on this. Because this is the periapsis that I'm paying attention to. Once it goes below 200, I am going to let it go. And once it also achieves the interplanetary orbit there that we want. So it's a little bit slow going right now, but I'm going to thrust up a little bit here. Are we going to miss? Maybe it's because I started a little bit too early, but it looks like we might... Oh, there we go. And there. Oh, did that put us in a really... Oh, there we go. Nope. We did it. We got the orbit that we wanted. It's not, again, exactly as we planned it originally, but we now have achieved what we want to escape from Kerbin. So, that is what we were aiming for. Now all we have to do is coast, actually. Our thrusting is over, so all we have to do now is commit to the science, and we're done with this experiment. So, simple, not too tricky. I still need to figure out orbits. Okay, so let's get back to our vessel now, and now that we've gone through the effort, let's appreciate the sight of us leaving our home planet and moving on to the great final unknown. Get up time a little bit more. Our planet becomes a black sphere in the distance. That might have been our final Kerbin sunrise just now, because I don't believe the sun's going to eclipse the Earth at this point anymore. We are approaching the moon. According to our orbital chart here, something funny happens when we get close. See how we have a blue line, but then it suddenly switches to moon encounter, and the line turns orange? That's because we are currently within the sphere of influence of Kerbin. But once we get close enough to the moon, we will enter a new sphere of influence, and the meter at the bottom there, the ball will switch over to compensate for the fact that we will be encountering the moon. There's the moon, getting to where it needs to be in its orbit for us to encounter it. We're going to keep spinning up a little bit more. And you'll notice that the ball should shift about now. See how it switched? That's because we are now entering the moon's sphere of influence. We are very close to the moon now. Let's take a look at this. We are about, let's see. We want to get a little bit closer so that we go from kilometers into the meters section here. It's currently measuring kilometers. Getting ever so closer. Looks like we're dipping beneath the moon on this particular excursion. There we go. So I'm not going to conduct it yet, but I'm going to try to use our Science Junior now and see what it measures it as. High space over the moon. Yes. Looks like we can transmit it for about 15 science. That's not exactly 75 science as you might believe, but we can't exactly recover this craft now that we've put it on an interplanetary trajectory. Well, I mean, we could, but then we wouldn't get the interplanetary science, and that's going to give us a lot more, considering it's just a space probe. I mean, just a satellite, rather. No, space probe is accurate. I'm going to put us actually a little bit closer to the moon, because I believe we can get different kinds of science as we approach, as we get under 300 kilometers. Sort of like how we were with the, with Kerbin. Look at that. I can't wait to get there. This is our first step to the moon, so let's bask in the view. Let's see, almost nearly there. We are going to... There we go. Okay, so I'm going to conduct some materials-based science. High space over the moon. Maybe we need to get a little bit closer to have a different result here. I am going to get us closer to under 200 meters. We're not going to go much further than that because the trajectory that we want to have does not allow us to go any deeper down. High space over the moon. Okay, so I don't think we're going to get any closer. I'm going to transmit this data now. Unfortunately, it does render this Science Junior inoperable, but we don't really need to worry about it anymore. Okay, so that experiment was complete. How is our... okay, what I'm going to do real quick is I am going to reorient the craft so that it looks to us as though it's standing up, but in fact... it will be in a position where it can perpetually attain some energy from the sun, because we do have a ton of solar panels on the system. See now how we've done that, the electricity is going back up. Doesn't need to be perfect, but I'd like to be able to have a consistent charge from the sun. And now that we don't have to worry about the Kerbal blocking us, the Earth blocking us, we should have a constant source of energy from the sun. While we're here, we're going to observe the mystery goo, which gives us barely any science at all. This will probably have to be a mission that we conduct once we have an actual manned mission in orbit around Kerbin, which will be our next step. So, unfortunately, not too much science here, but we're going to transmit it anyway because we can. Plus 8 science, again, not much. Typically, science is a little bit more effective once we can actually get a return mission, and returns are easier when we have Kerbin returning to the planet. So, not too much science this time. This might actually be all the science that we can conduct while we're here in the planet's sphere of influence. And in fact, we are almost out of it, too. We're about halfway past the moon. Let's see if there's anything else we can do real quick before we officially leave. It's inoperable. I think we're done at the moon, actually. I'm just going to take one more look at it to sort of appreciate where we're going to be landing soon. Look at that. Alright. Our goal is not too far away. We will have many missions to this place. Lunar 1 is only the first in many. Let's see. Okay, so I am now going to, while we're here actually, I'm going to speed time up a little bit so that we can get away from the moon. Look at how it gracefully disappears into the distance very slowly. Look at that, the sun, the moon, and the earth almost perfectly aligned. It's kind of a magical look. As we drift away further and further away from the Kerbal system, we will be in, let's see, we got to go all the way over there for a Kerbin escape within 6 days. So I'm going to speed up time so that 6 days can pass and we enter interplanetary space. And here we go. Okay, ladies and gentlemen, we have achieved interplanetary space. We are now on a new kind of orbit called a heliocentric orbit that has us going around the sun instead of the Kerbin system. Now that we're out of the Kerbin system, we don't really have a practical way back because our thrust, I don't believe, right now, the way we're positioned, is enough to get us back to Earth. Or Kerbin, I'm sorry, I keep saying Earth. But while we're here, we can conduct a little bit more science. Again, making sure that our solar panels, at least some of them, are facing the sun at any given time. We are now going to conduct a little bit more science, starting with our Science Junior. That gives us 55 science. 55 science, even transmitting at 20%. We can get 275 science from keeping the data, but the inherent problem with that is that we can't really recover this mission by getting it back to Kerbin, so we are going to transmit the science instead. And there we have it. A bit more science on our journey here. While we're in interstellar space, I guess we can observe the mystery goo, which will give us 33 science as well. And again, more practical to transmit than to try to get this thing to return. And there we have it. We also have 2 more of our liquid systems up here as well, but they're not going to give us any new data because we've already achieved that. So, this is more or less the end of our current mission with Luna 9. Luna 1 is currently in heliocentric orbit, and it's going to be a while before we can actually do anything with this, if there is any opportunity to do anything with Luna 1 ever again. We have put a landing system on it, including a parachute and a gear and landing legs. And, as a matter of fact, we also have a bit more thrust in our liquid fuel. We still have about a little bit less than half of the thrust that we had before. It is possible, although very unlikely, that we might be able to put this in a trajectory with another place. Given the way this is built, and the parachutes and the landing gear, it would only be practical for this to either return to the planet that we have now, or to put it in a new planet altogether. I don't think we could put it like on the moon or anything. So we could set on a course to have it intercept Eve, the planet out here, which does have an atmosphere. It's like Venus, it does have a very thick atmosphere. Or we could wait for it to give it a orbit back to Kerbin, in which case we could thrust back. And I guess we could collect some more data to keep instead of transmit, which would give us a little bit more. For now, however, we don't really have an opportunity to return back, and I suppose we could try to set a maneuver. Like, maybe if we set the target to Eve, we do have these nodes right here. We're getting a little bit further ahead into what we could be doing. I don't think I'm ready to try interplanetary travel. We can try seeing what happens real quick if we adjust our nodes here by giving ourselves a retrograde burn. See how the nodes here give us a closest approach estimate. The idea is that we'd want to give ourselves an encounter, and I don't actually feel like confident trying to put ourselves into another planetary encounter yet. So we're going to leave Luna where it is. Luna 1 is now on hiatus. It is possible that it will one day give us an opportunity to land somewhere, but now I'm rambling. I'm going in circles. This actually concludes our Luna 1 mission, which gave us a chance to explore the moon, and maybe eventually another planet. But for now, Luna 1 is on its own peaceful journey. So, our mission with Luna 1 is now officially over. I'm repeating myself over and over again. There we have it. So we've got Sputnik around Kerbin and Luna 1 around the sun. Our next mission is going to be an orbital one. Instead of going and doing a flyby, we're going to orbit the moon instead. And we're going to do that with a real astronaut this time. So that'll be a little bit more involved, but since we did a little bit of science there already, although minor, we might not need as big of a payload to arrive there. So, in our next mission, we are going to go to the moon with an actual astronaut. Until then, I'm sorry, I can't speak. Until then, this is Ardwick. Stay tuned and good night.